after we've loaded the light curve, we can check to see if there's another secondary star that maybe even has a better light curve, and that's done in this secondary data column. We see that the primary is already loaded. That definitely is an occultation event. So we'll leave the primary loaded in column 11, but let's look in column 13 for another secondary star. That one's blank. So there was only one other secondary star analyzed in this analysis in LiMovie. Our next step would be to go to process timestamps, and we hear a little bell click, and that tells us that there may be a window that's appeared behind our Google Chrome screen. So I'm going to press Alt-Tab, and that brings that window to the front. And that window says that the file must be in R-OTE format before timestamps can be processed. So, first thing I do is write the file in R-OTE format. And down below here in our RStudio screen, we can see that we wrote the file in R-OTE format. So now I can go to process timestamps. And on this menu, we see that we have a video type of NTSC already checked. That's the type we want. Our time delta is entered for that type. So now we need to enter our camera delay and our VTI offset, if appropriate, into our menu items. So how do we determine that? Well, we're going to go to the original user report that we get from the observer. So we have all of the original user report files filled in, and we can go to the corrections tab at the bottom, and we can look for the camera that's in use, the PC165 DNR, and it's operating at 4x. So the delay for an EIA or an NTSC camera is a minus 0.0667 seconds. So we'll click on that and copy it, and then we'll return to our R-OTE page and we'll paste it. And then we want to look for the VTI offset. That's also on the corrections page. It's in this little yellow goldenrod colored box, and it shows that depending on the type of video time inserter used and the software used for the analysis, you should either apply no additional correction or a minus 0.1667 second adjustment. So if we go to our data table, we see that the timing device was a Kiwi OSD, and the Kiwi OSD, and we're using R-OTE for the analysis, so we're going to apply this minus 0.01667 correction. So we're going to copy that, and we'll go back to our R-OTE page and we'll paste it. So now we've got our corrections. Next we'll look and see if there's any VTI timestamp issues in this file. So we press the plot VTI analysis, and another screen has popped up. We can find that by going Alt-Tab and pop it up that way. Or, since it's behind the Google Chrome, we can also look down here on the taskbar and see that it's popped up. So either way, we can find that screen. And it's found no OCR errors. Well, it found OCR errors, 10 of them, and corrected them. And it's found no missing frames. So we have a fairly valid sequence of timestamps, so we can proceed with validating the timestamp. To validate the timestamp, we select the first frame in the file, and then we select the last frame. We can do that because by looking at the number of frames is less than 1500. So if I put 2000 into this box, it clicks onto the last frame, and then we're going to look at the span of these frames and see if the timestamps agree with the frame rate. And we do that by clicking this button, Validate Time Span. And R-OTE says that all of the frames are valid, and so now we can add this valid timestamp to the very first frame. All we have to do is change the date to conform to the date on the file, which is 2016 November 12th. So we'll go 2016 11/12. And then we add that information to the file comments. And that appends our corrections and our timestamp information to the file. So now we're ready to do an analysis, but we know that this file is integrated. So our first step would be to block integrate the frames into single points. And we can see that easier if we zoom down on the file. So we zoom in on the file, we can see that there are groups of 2 dots together, and this is indicating that we can validate that in fact it was a 4x integration, 4 fields, 2 frames per field, or 2 frame dots, and what we need to do is block integrate these 2 frame dots down to 1. So we're going to use the block integration routine at the bottom of this menu. First thing is we want to show the integration blocks, and it colors each data point alternately red, green, depending on the block size. So right now the block size is 1, but we think there's 2 data points per block, so we're going to click up to 2, and now it's coding each 2 points as red, green. What we see is that these points seem to group correctly, and if they had not grouped correctly, it would be because maybe there was an offset at the beginning. Maybe we started with just 1 of 2 points, and we can change that offset with this toggle. But in this case, we're not improving the groupings, we actually made it worse. So we'll go back to the offset of 0, and now we see that the groupings are appropriate. We're going to save the block integrated data. That means for each 2 data points we're going to get 1, and then we're going to load that file just saved. And up here now we're going to have a new file. We used to have 1500 data points, now we have about 750, and we've got a new file, and that's what we're going to do our analysis on. Now, our next step is that our light curve is not nice and flat in the baseline because we had some sort of atmospheric extinction affecting our data. So we're going to take this regular light curve and normalize it to the secondary light curve. So we're going to go to the menu item, normalize to secondary, and this particular routine allows you to return to this particular light curve. If we try and normalize it and we don't like the results, we can return to this by restoring the plot data. But to do that, we have to save the current plot data first. So we're going to save it, and the current plot data is saved. We have to press OK here. If this window happened to pop up behind the Google Chrome screen, we just press Alt-Tab and get that window to the front, and then we have to press OK to proceed. We can just normalize against the light curve as is. That's one way. So let's try that first. We're not going to do any smoothing. We're just going to normalize this curve to this curve, and we're going to pick a point that's highest in the secondary curve, which happens to be around point number 1. So we're going to leave the normalization point as number 1. We're going to say normalize against secondary, and we hear a little bell ring, so let's see what is hiding behind here. It says the observation will be normalized when this message is closed. Do not press the button again. If you press multiple times, you actually normalize the light curve again and again, and then you'll actually mess it up. So only do this operation once, and if you don't like the results, go back and restore the plot. So we'll press OK, and now the light curve is normalized. So you see that there's a fairly bright spike here, probably because of this little drop down here. So we can choose to accept this light curve, or we could say, I'd like to smooth this light curve. So let's try smoothing it. So let's restore the data plot, and this time let's smooth it. We'll try 7 times. Some small number, 3, 5, 7. We can try whatever looks reasonable. I'm going to try 7, smooth the secondary data, and now you see that we've eliminated some of the real big spikes, and now we're going to normalize against the secondary again. Here's the little bell. There's our window. I pressed Alt-Tab, and we'll press OK. And we don't get that big spike up that we saw there, and that looks like a pretty reasonable light curve. So let's use this in our analysis. So now that we have a normalized light curve, we're going to write that result to the file. And if I get rid of this, we can see down below that we've written a new file named normalized to secondary to the directory. And if we go to the original directory, we now see that we have some new files that were added. We have the original CSV file. We have an R-OTE version of the CSV file. We have a block integrated version of that CSV file, and now we have one that's block integrated and normalized to the secondary. So this allows us to keep track of what we did, and it allows us to come back to the highest level file if we ever want to redo this analysis. So we want to work on that file, so we're going to load the file just saved. And now that's the file of record in our data set here.